In this video, we will anti-differentiate the function tangent of x. Now, looking at this function that we'd like to integrate, tangent of x, how the question is currently asked, we either A, have to just know the antiderivative off the top of our head, which we most likely do not, or B, we have to somehow rewrite the function to put it in a form that we can work with. And a little bit of intuition here is if we think back to how we would differentiate this function. When we came up with the rule for the derivative of tangent, we said let's first write it in terms of sine and cosine so that we could then apply the quotient rule. Same idea applies here. We rewrite the tangent in terms of sine over cosine. And once we've written it in terms of sine over cosine, now we see this is in the form that we are looking for when applying a substitution. You really do have this inside function. You have u, which could be cosine x, in the denominator of a function. So if we let u be cosine, then du is minus sine dx. So the sine x dx left over is going to be equal to minus du in this case, just bringing that minus sign over to the other side with the du. So putting the integral solely in terms of u, we'll have a minus sign that pulls out front, and then we're left anti-differentiating 1 over u. And once again, just to make this big picture observation, the substitution doesn't solve the integral for us, but what it does is it takes a potentially difficult integral, i.e. tangent, and rewrites it in terms of this simpler, easier to evaluate integral. So this antiderivative would be the natural log of the absolute value of u, and then we finish by just resubstituting. U is equal to cosine x. So minus the natural log absolute value of cosine x plus c. Now, one further simplification we can do here is remind ourselves that a constant outside of a natural log, and here the constant is minus 1, can be put inside the natural log as a power. And when we do that, it will be the natural log of cosine to the minus 1. So that would be 1 over cosine, or the natural log in this case of secant.